Number 14, it says to find the Taylor series at x is equal to 0, or the Maclaurin series for f of x equals x cosine of square root of x. Okay, how can we approach this? We can, of course, do the brute force way, take derivatives, plug in x is equal to 0, try to find a general pattern. I would definitely not recommend to do that in this problem. Instead, let's start with a known Maclaurin series, or known Taylor series. Hopefully you know this, I should say, and have it memorized. What is the Maclaurin series for cosine of x? Let me go to my PDF. So if we remember that, is summation as n goes from 0 to infinity, -1 to the n, x to 2n over 2n factorial. So how I remember it is, I more so remember the expanded form for this one. It's 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial plus so on and so forth. So it alternates signs, and it's only the even powers. Okay? And how do you remember if it's even or odd? Well, remember cosine's an even function. So that's how I remember it. I use that to my advantage, okay? Okay, so we start from here, and remember we can treat these like functions. So we want to basically go from cosine of x to the guy we want over here, x cosine of square root of x. So what do we need to do first? Let's, like a function, replace this x with the square root of x instead. So wherever there's an x on this side, we replace it with square root of x, like I did right there, okay? That's the only x term, actually, on the right-hand side. All right, and we can simplify this too by properties of exponents, just x to the n, okay? And what's left? Well, to get from this to this, we just need to multiply by x. So we multiply both sides of the equation by x, okay? So we get x times this guy right here, which x we can, it's not dependent on n, so it's like a constant. We can either move it in or out. Usually we move things out to make this inside the summation. You can get rid of terms that don't depend on n to kind of clean it up, is what I'm trying to say. But in terms of simplification, we can move that x back inside, actually. So we would get x to the n plus 1 power. There's the extra power of x. So imagine there's times x here. So we can combine those by properties of exponents. X to n plus 1, okay? And that's your answer. So this is pretty simple, in my opinion. And I would say this is a very typical problem that you can expect for any university or any college, at least in the States. All right. Hopefully this was helpful. And please give this video a like if it was. And hopefully see you in another video as well. Bye.